Andrew, what's up, Andrew? How you doing? Can you hear me? Just give me a wave if you can hear me. Got you. Just give it a few more minutes. See how this thing work. Andrew, where you from? You can type in the chat. But tell me where you from. See what we got going on here. Ohio, all the way from Ohio. That's what's up. Just give it a few more minutes and we'll start. Let me see if I can find some background music. That's what I need. All right, let's get started. Got a couple more joining in. So I want to welcome you to the EST3 Rule Architect. This is a live 8-week event where we're going to be going through the entire software or the EST3 SDU. It's going to be not a slow pace, but it's going to be broken down into 8 weeks. So I don't want to cram everything all up into the first week. But this first week is generally just the foundation. So if you are a beginner to fire alarm system, or if you have some type of experience with fire alarm, this is going to be the training for you. So I want to go through this quick little presentation before I show you what the Rule Architect is. This is a tool I created that you could actually use on a day-to-day basis. Actually, you could put your scenario inside of it and just spit out the rules. It's not 100% accurate, but it'll give you a little bit more detail if you need some help when it comes to writing rules. So who am I? My name is Anthony Richardson. I've been in the fire alarm business since 1999 for quite some time now. Started with a company called Fire Quench, and Fire Quench is usually the starting point for a lot of fire alarm technicians in the city of New York. It's kind of one of those rough, I want to say it's kind of one of those in and out revolving doors type of situation. The owner's a little bit obnoxious. Everything is fast paced. Everything's good. But I learned a lot there. Really, I learned nothing, but I actually learned a lot because it was one guy who actually showed me how to understand relays and wire up relays. And from there, I grew my experience working with Simplex. That's where I got most of my information from. Really, a lot of my knowledge. I was there for over a decade, and anything they went to training, card access, cameras, all types of fire alarm systems. That's what I did until I left them, went to Red Hawk, and I started learning the Edwards panel. So I want you to know, so what will you expect, or rather what you could expect from this 8-week series? Within this 8-week series, it's designed for beginners, mid-level fire alarm technicians who want to move from basic wiring to troubleshooting to think like an actual fire alarm programmer. Because what I mean by that is it's one thing to just know how to program a system, but you have to understand what the codes are. So if you understand that when the smoke detector go off, these particular output functions are supposed to happen. If you can envision that in your brain, it'll be easier for you to write any type of program or any type of software. It doesn't matter the system. It's just what you would have to learn is the syntax, or how that code or how that particular system write their rules, custom controls, or how they call it. Because from Simplex to Edwards, it's 100% night and day. So you would really have to understand why the input action happened and what output activations have to follow along with that. But more specifically, excuse me, when it comes to Edwards, I'm gonna show you how the rules work, what the syntax are, and I'm gonna show you some real programming strategies inside EST3. So if you have a laptop, you have the software and the key, then you can follow along. So what you will walk away with today, like I spoke about earlier, is I created a EST3 Rule Architect, and I'll show you exactly a demo of what this can do and how this can actually help you out in the field. So like I said earlier, today really is only going to be about just the foundation. I know we want to get straight into writing custom controls, writing rules for, let's say, purge or speaker system with the N variables. I'm going to show you how to use all of these syntax. I'm going to show you how to use all these input variables, output variables, equations. Edwards call them rules, Simplex is equations, but I'm going to show you how to write these rules step by step inside the SDU. So what are rules? Rules are the programming language that Edwards Fire Alarm Panel, the SDU, the programmer, it uses to communicate with the fire alarm control panel via the CPU once you download the system. So you make your changes on a laptop, get your rules, get your inputs to activate your outputs, and then you will download that into the fire alarm control panel so that way those functions can perform. So the core syntax breakdown, which I only have a few here, there's a bunch of input events and there's a bunch of output events, but I only selected the most common ones that we normally use, and that's the alarm event type, supervisory event type, switch, and on the output side, we turning on fans, shutting on fan, we turning on amplifiers, shutting on fans, or turning on exhaust fans, and we doing things with the LED. So I'm gonna show you what some of the input functions look like. For the alarm type, An alarm event activates when a specific point panel goes into alarm. So if I'm using the point type or the device type, if you see here, it says alarm, smoke, and then we have level 1 smoke. So alarm is the input event or the alarm event. Smoke is the actual qualifier. So we want, when the smoke goes into alarm, what type of smoke, or rather what message, what label is attached to this smoke. Because if you have multiple smoke detectors, you're going to have multiple labels. And I'll show you what that look like inside the objects label inside the SDU. So we're telling that on the input side, when a smoke goes into alarm, this particular smoke with this label, we want some things to happen on the output side. And we have also supervisory. We could write supervisory rules where we could make tamper switches do some things, or we could have either whatever supervisory point that the system sees, we could actually have an output activation. So if we press in a switch, we can turn on a horn, or if we press in a switch, we could disable outputs. So there's many different things we could do inside of the programmer. Going back to switch, we usually can use switches to either, let's say, disable certain floors. We'll have a test disable switch, or we could disable the whole entire building. We'll have a switch to do either a fan restart or even to turn the fans on if we're trying to do a purge. So a switch is something that a button you can press to either turn something on or to turn something off, and you will write that in the rules. So some of the output functions we have on. Now, if you're not familiar with high-rise buildings, or let's say assembly type situations, or in any large facilities that would need some type of voice enunciation, this is where you would put the amplifiers in. And if you have multiple amplifiers, when it comes to Edwards, you can write just one particular rule to activate multiple amplifiers and use that with the N variable. And we'll go into the N variable when we start getting into the SDU in the coming weeks. Another input type, or rather an output type, would be fan on. We're doing these to control the fans. We want to shut the fans off. Any fans over 2000 CFM requires a duct detector, and it requires to be shut down. So if you have a fan that you're connecting to the fire alarm system, that relay will go to dry contact, or if we have an MR201, we're cutting it off with the power. Some type of way we have to shut that fan off if the fire alarm control panel goes into alarm. And this is what an LED switch look like. They have the 1224, which is 12 switches, 24 LEDs. This is a 1212, meaning that it's 12 LEDs and 12 switches. The 24 would have 2 lights or additional LEDs, one underneath each one of those LEDs. So you can do different things. So when you press the button, you can have the top LED do something. And when you depress the button, you can have the bottom LED do something else. So it's a bunch of different things you can do when it comes to the fire alarm system. Trying to conduct business, go live, your phone is ringing. What are you supposed to do at that point, right? So if you got any questions, let me back up. Let me slow down because I'm just running my jibs. If you got any questions, let me know if you got any. We go back to the back and see what we got going on here. So let me know if you got any questions, and we could answer your questions. So let me show you what this architect look like, right? It's pretty cool, actually. So in a nutshell, and there's a PDF that you can download, cheat sheet that has put a bunch of the rules in there, a lot of the syntax, what they mean, how you can use them. It's a little bit more explanation. So at the bottom of that PDF, link, and you can click that link. So if you have a real live job and you will put your rule label is what will describe that actual rule. So if it's recall or elevator recall, we would just put elevator recall. This will be describing. So now I want me to input the characters. I'm not going through all of that because all these is optional. You can put that in there so it could actually spit out exactly what you want, or you could just hit the example and it says when a fire drill switch is activated, I want you to turn on all the audible devices. And when you scroll down to the bottom, you click on generate rule, and at the bottom it'll give you generic rule. So switch, because switch is the event input, and the secondary switch is the device type. So you have the input label or the input event device type, and then you have the device label. So the first switch will be the input event. The second switch will be the device type. So now if this was alarm, the second one will be smoke or pull, whatever one you're activating. So to understand, you will have your input event, and then you'll have your device type, whatever you're activating. And then that label, which is fire drill switch, and you have the label for that particular device type. what you're going to do on the outside, we want to just turn on the audibles, and that's the horns and strobe. So this thing right here is very user-friendly, very easy. You can load it, quick examples like door holders, generate the rule, to give you a generic rule. And all you have to do, if you're writing rules for Edwards, just put your labels and boom, you have your information right there. This is brainless. So I want to go really quick and let's go inside and start a whole new entire project. But before we do that, let me show you what we're going to base this off of. So we got a set of fire alarm drawings here. This is an actual project I did in a church in Brooklyn. We did a few years ago, maybe like 6 years ago. It's like 25 duct detectors, I think, we electricians installed in this building. But I'm gonna just go through this cellar level, and I'm gonna just add a couple devices, smokes, some ducts, some input modules, stuff like that, some horns and strobes. We're gonna go through the entire process. I'm gonna write all the rules and add the devices, go through the whole thing. All right, some basic in general. So let's go do that. So when you first start a project, what you need to pay attention to, if you're doing some programming, you definitely want to pay attention to like operations. This guy over here, this is what will tell you how to program the fire alarm system. When a manual pull station go off, it's telling you all the output activations that it should happen. So when you understand not just programming fire alarm system, you really understanding the ins and outs of this entire thing. So when you're facing yourself with a question like, how do I make this happen, just understand what output events are supposed to turn on, and it should be easy to write that rule or whatever program you're working with, drag and drop your inputs to your outputs. So let's go over to the SDU. Excuse me. So you would click on project new, and you would give the project a name, and you would give it a password. And this password you can use password you will have to use every time you log into this particular application, not the Edwards, but this particular software. So you can have multiple projects with different passwords, which would be nuts. But if you have multiple projects, you want to have the same password for each one. We're going to just do it real quick. This is the banner. This is what you will see when the system is normal. So it'll say something like 3 main lane or main street. Bottom it'll be like system normal. So when the system is normal, this is what it will display. Operation tabs, this is usually all left default. Timing, this is also usually all left default. This is pretty much just like the resound. The only one that stays, the only one that have a time is your test timeout and your trouble resound every 24 hours. If the fire alarm system has a trouble by code, it has to resound every 8 hours and say, hey, I'm still affected. I have a trouble, call the fire alarm company. Network, you will change this if you're putting in or if you're connecting multiple panels, or if you have a remote annunciator. The trouble reminders, the same thing as this timing tab over here. 255 seconds is 255 seconds. This is for, I don't know what the hell that's for, I'll tell you the truth, because 255 seconds is not eight hours. As I was just thinking about it. So just X-nay what I was saying on this one. This probably is related to if you have audio. I'll figure that out next week. Here's your time zone. So now we have our project information. Yes. And then we just click OK. Now you understand what I can't get the. All right. So let me see if I could pull it up. So inside of, you would have to know this if you're, especially you'll probably be in the field. Let's say you're in the field. You're looking at the fire alarm control panel and it's just a small system. This is what the bay looks like behind it. So these first 4 slots will be the CPU. Then this next slot right here will be your power supply. Then every card after that can be whatever. So let's say this next card right here would be our loop controller. And this is where we connect all our smoke detectors, pull stations, all our input devices. And these will just be our spare cards. And we'll probably have a mod com for central station. But the main cards will be the CPU, the power supply, and the loop controller. So essentially, this is how it would be set up. And when you have your whole system set up, they have 2 different layers, right? They have a hardware layer, which consists of the actual cards. And then they have the software layer, which will consist of the actual buttons and switches. And I'm going to show you what that look like. So we have an idea of what type of system we have because we just have a small system, CPU, power supply, and a loop controller. So inside here, what we're going to do is we're going to add a cabinet. That's crazy. So here we're going to add the loop controller, just like a single. Let's say like we only have a small system because they have a single, and then they have a dual loop controller. That's with these guys over here. So let's just put it in a regular single loop controller. Then to access that menu, it will be LRM config. So that way we can get to the actual loop detectors, loop modules, and the second modules and detectors. So for smoke detectors, we're only going to add one smoke detector. It's a photoelectric smoke detector, and all that other information will populate and automatically. So we'll click OK. Label text, I like to do the label text when I'm inside the objects label, but for argument's sake, we're going to do the label text here. I like all caps. So I usually go smoke, or you can go smoke. Or let's say if you have like it's a high-rise building and you lay floors or 3 floors, they usually write it like this: level 1, whatever level it's on. You can start with 0 if you have a basement, 0 if it's just the first floor. So level 1 will pertain to the floor. Level 1, level 2, level 3, level 4, and so forth and so on. So it'll be level 1 smoke. So that way, if you have multiple smoke detectors on level 1, then you just put another hash, and then you go level 1 smoke 1, smoke 2, level 1 smoke 3. And when you write your rules, this will start to make sense. So we add our detectors, we add our module. Let's say we're going to add a CT1. Yeah, we're going to add a water flow, and it's just a CT1 because they have a water flow module, which I don't use those, but we're going to have a regular water flow. And and then the water flow is going to be normally open latching, because out here in New York, we non-silencer where you can't reset water flow switch, so it has to stay active and alarm. You have to physically reset that water flow flapper, that alarm, that module, whatever it is. You have to physically reset that in order to reset the system. So we'll close that, go inside the power supply. We got going on over here. Do we need to add anything else? No, we got my account. We're not doing nothing else. So the port, if we're gonna have printer, it's gonna be auxiliary port, supervisory or CDR printer. Usually, the old systems will have a coder. Have to put a CDR3 printer, which is actually a coder, so that way it can send the rounds out for the outputs. If it's a pull station ringing 414, the coder will ring it out 414. Options, baud rate is usually 9600. You don't normally change that. Log history is everything that's going to be logged into the history, whatever events that happen on the fire alarm control panel. Let me see, we got those modules in. So now the hardware layer, like I said before, is our cards that we have. The loop controller, we're going to connect to the loop controller with our laptop and the serial cable. That is how we're going to, to the loop controller. That's the hardware layer. But on the operator layer, this will be our switches. So we can add 112 LED, one switch. So here, all on the left side is toggle, all of our LED, that's all of our switches. So now we have toggle, interlock, and momentary. Toggle is, you press it, it back. So on, off once you press it. Interlock is light switch. You press it, turn on. You press it to turn it off. And momentary is pretty much the same thing as toggle. You on toggle or momentary switch. So it'll just be on for the second. You will put your label. This is going to be a fan restart switch. And that is only one LED. That one LED is already associated with that one switch. But if it had 2 LEDs, you will see a lot more of menus down here. You'll see 24. You'll see a lot more rows that you can get to program those other LEDs. But this is only a 1212. So we'll close that, and we'll go over to the configure, and then we'll go over to the objects label. Now, inside of the objects label, this is everything that's connected to cabinets, all of the cards, everything that's connected. So if you have multiple panels, all of your panels will be here inside of each one of your panels individually. But how I do it here is I'll type on a device type and just start typing what I'm looking for. So that's the smoke. And what I want to do is give it a message, because this smoke is on the first floor elevator lobby, which reminds me, I got to add a relay. So let's add back and add a couple relays. So we go to the loop controller, config, loop 1 modules. When you upload, so select everything is already installed. I'm ahead, but everything is already installed, and you site, the electrician ran everything, wired everything, you power the panel up. Now the system is mapping. When you connect to the fire alarm control panel, the CPU, and upload everything, that is when you will do your matching on the map, and you'll have your serial number. So let's add some relays. We need some output activation. So some non-supervised outputs. So a non-supervised output could be anything, actually. Let's go with the supervised output. So a non-supervised output you would use for like a relay, like a door controller, something like that. So what we have is a CC1 for audible, and then I want a visible, and then we're gonna add a relay, a regular relay. Let's say for for door holders. So we got those three. So we got relays. Now we go back over to the objects label. So we have our devices. We can scroll through this one at a time. So if we just click back on the menu, we can scroll through this using the up down arrows on your keyboard, just to go through this one at a time and find out if there's any labels and messages you need. So what is this audible? So we're just going to do a quick AUD1, and this is first step B. And you only have 80 characters. You could max it out, and then you can get more over there, but you don't want to do that. First floor stair B, you want to keep it nice and neat. What else we got? We keep scrolling. Of course, you can hit the first letter of the device type you're looking for. Excuse me. I'm sorry. You can hit the first letter of the device type you're looking for, and it'll give you that menu. So we have a bunch of LEDs that we have to fill out. So we don't want to type them all in, right? So let's select them all. Let's hide this. We're going to select them all. Then we're going to hit the prefab label. We're going to go fan. We want to replace a 1. Let's just switch 1 after. Let's see if this works. No, it didn't. Let's do that again. Let's try that. No, it didn't do it again. Oh, I got you. There we go. Sometimes you got to use the brain power. So essentially what I used was the wild card, and I should have saved it. I used the wild card, right? This wild card will represent any character. So wherever you use this wild card is going to assume all of these characters. And my start value was 3 digits of 0. You can just 1 digit. You can use as many digits as you want. I just used the default. So that's how you use a prefab label. So if you have 100 smoke detectors, this would be a good way you could label quickly 100 smoke detectors. So we got our LED straight. What else? What is this? This could be our door. So let's call this door 1. Give it message. We're gonna call this first double doors. Did I spell that right? So you see we got D and ORs. So what you do is hit the space bar so you can go over to the next line, and that way you can have a nice clean label. Corridor. I guess that's right. Okay, we got switches here. So let's go back to the prefab label. We're gonna go switch _* and let's do just 1 digit, and then we replace it. Shit. Switch. Boom. Yeah, that was right. Oh, see, the brain ain't braining. You got to pick them. Sometimes I just be losing my mind. This is what really be happening in the field too. And a lot of problems I be having because I'm not paying attention and I'm causing my own problems, figuring out like what the fuck is taking so long? What's going on? And then I calm down and be like, oh man, damn. It's all my fault. I just wasted a half an hour on something stupid. But hey, this is how we learn. So we keep going. So we go with Viz. We keep it simple. So this is gonna be first strobes. And we got the water flow. First water flow. And I just go WF1. Then we just do a quick check to make sure everything, these spots. And especially if you're working on a big system, I don't like going back and forth. So I usually will go through this, right? And I'll write down the things that I need to write down. Like, show you. So audio 1, we know we're going to have to turn that on. So I want to write down exactly this message, this label text. I want to write that down exactly how it is. Because when I get to the rules, I don't want to be coming back and forth from the rule sheet over to the objects label. So we got the fan restart. We're just going to use the first button. And when I actually get my EST panel live, we'll actually go through this live so that way you can see this actually in effect. It's going to take a couple weeks. So we got the door holder stuff down. We got the input. So LVL1 _ smoke. We got the switch, we got the visibles, which is the strobes, and the water flow. All right, so now what I do now is head over to the rules. Now inside of the rule editor, there's syntax you have to be aware of. If you're using the French brackets, these guys here, anything inside here will be ignored. Anything inside there will be ignored. So everything outside will not be ignored. So usually this is a place where you can put your name, company you work for, phone number, guy who programmed it, things like that. So the rule label, the first rule we're gonna write is we're gonna activate smoke detector. Now back up. There's a gens editor that comes with the EST program. If you're not familiar with how to write rules, the gens editor will help you. It's color coded to let you know that you have the wrong syntax, you have something you got to fix, so that way you know it's correct. But I don't use the gens editor, so we're just gonna freestyle this and compile it to see if it compiles, and then make some changes to make it compile. So we want to write the rule, which is what is rule label? What are we doing? Let's just say smoke activation. So we got the rule label. Into that we go alarm smoke, and we could use SMK or S or spell the word out. Now a lot of things that what I use a lot is the help topic, right? So if you're sitting there trying to write rules, trying to figure out what qualifier is or whatever you're trying to figure out, you can just go straight to the help. You go, okay, this is how I can write the rule. This is what can work with it. So that way you get more information on how you could actually write this rule. So if you're using the rule, you can use these device types like smoke, the second label next to it. So it'll be alarm and general alarm, heat, matrix pull. These are all the qualifiers you can use on the device input side. So we're going to use alarms, and then we write that exact label. So level 1, and the system don't like spaces. You see this space right here? It don't like spaces. You need the underscore. The underscore is what it needs, because every is a character. So if you're doing a space that's empty, it's going to assume that that's calling that a character. So if you write in your labels with no spaces, just make sure you write your rules also with no spaces. So spaces or no spaces. So level 1 smoke underscore 1, and then we have to put this whatever the tag is, and then we have to put the semicolon. And usually I like to do it like this, right? I don't know why, but that's just how I like to do it. Like one on one side and one on the other side. And then what we want to do is we want to turn on. So we could either go non-output on, like we could look at the help. So we got the on command, and you could have a priority level. The priority level will dictate you take precedence over it or not. So if you have like delay, say like you have startup delay for the fans, each fan, you got, let's say 10 fans, you don't want them all to start up all at the same time. So you'll put a priority delay on what to start first, what to start next, and who or what else can override it or not, depending on their priority level. So if you have like a which, that will probably have a higher priority level, so that way it can cut everything out. So priority levels will give the input priority if you turn it on or turn it off. And it's from 0 to like 99, 100 or something like that. So the device types you could use on the output side, we could turn audibles. So we have audible right here. So we're going to go on the on command, which is after the semicolon. So we're going to go on audible. Then we have to put these quotations or quotes, whatever that is. And then what did we write down? AUD underscore 1. Then that quote again. And being that I want to check this, I'm going to end it with a semicolon. If I want to go on to the next rule, I'll use a comma, but I want to end it with a semicolon, and I want to save this, and then I want to compile this, right? So the rule actually worked. It's saying we have some warnings, right? So if you have warnings, that means the rule worked. That means that something is just probably is not associated with something, and that's all that's telling you. So warning is just as it's just a warning. So the rule is good. The rule compiled. So let's turn on the next thing. So what's the next thing? We want to turn on the visibles, right? So on visible quote VIS underscore 1, and then we're going to put the comma because we're going to add the door. And the good thing about writing rules, right? Because we got to write the water flow next. All we have to do is copy and paste the whole entire thing and then just change the input side. Now the water flow will activate the same outputs that the smoke detector activates. So on, let's go to door holders. Door control. No, I'm wrong. That's a non-supervised output. Remember, we had a non-supervised output. We didn't make it a door control. So we made it a non-supervised output. So we got to spell that whole thing out. Or if we click on this, we can use this, the short form NSO. So for non-supervised output, we put the quotes. What did we name that? That's the door holder, right? So door one is what we named it. What else I forgot that we got to go back and do? The LED. So we'll that out. We'll click OK. We'll come see what happens. Yes, we got warnings. Let's go. Yes to all. Boom. If you don't understand what's happening here, in a nutshell, is taking the letters we see or the characters we see, turning them into zeros and ones so they can put it to the computer and the computer can understand what's happening. So the rules is good. So let's go back. I need the LED. Oh, I made it a fan so what the hell did I do? Switch. Oh, I'm okay. I got you. And fan restart switch. This should have been LED. This right here should have been fan restart LED instead of switch. That's why I got confused. All right, so we go back to the rules. We edit rules. So we know that works. So now we want to do the water flow, because essentially if we have a fan restart switch, we should have another relay fan shutdown, but we don't. You should use standard here, because if we had another relay, it'd be on NSO fan _1. So let's copy this. Control C, and then we call this water flow activation. So we go alarm water flow, or we can go WF. And what's the water flow? What did I name the water flow? WF1. Everything back up. And you don't have to change anything on the output side. All you have to do is change the input side. And if you had pull stations, alarm pull. If you had any event or any other device type, it would be the same thing. The alarm device type and whatever that label is, activating all these particular outputs. So let's look at, so the short form is flow. Okay, so it's wrong right there. We'd have had an incorrect rule. So we go alarm flow. That's the short form. Alarm flow, water flow. Let's back this up. Let's save it and let's see if it works. Yes, we good to go. So I'm gonna do one more rule, and I'm gonna do the switch. So we're gonna call this because we don't have an actual can't spell door release. And you need these brackets. These are not the French brackets, but these are just regular brackets around the rule label. So door release, we're gonna hold switch because we're doing a switch, and gotta go back to goes to the help menu. So switch and switch, because switch is the actual input and also the device type. So switch, what did I name the switch? Fan, restart, switch. Then we put the quotes, have that over. Semicolon, you need a semicolon to separate the input from the output. So we're gonna go on LED, and then we're gonna go, no, this is wrong. This is the LED. So switch _001, remember? And the is named. Take a look. So yeah, that should work. Let's see. Let's click OK. Rule. Nope. Figure this out. That is 0, or those are O's. Like letter O. Let's see. There we go. Simple mistakes like that will give you a rule error from an O to a 0, and you'll be tripping like, what the hell's going on? Because it's 9 o'clock at night. You should have been home 5 hours ago. Panel crashed, and you the only one that can fix it. So once we do that, we'll go over to database conversion, all databases, so that way we could process all whatever many loop controller CPUs that we have connected to this system. Let it do its thing. Then you will take your cable, connect to the CPU on network. You will right click on your loop controllers, whatever loop controllers you have on the system. It'll bring it all up. Left click on the CPU, right click on the database. So that way we could just have just the information we want. Once we click everything download, it'll download to each one of the controllers, the CPU and also the SDU. All right, so the last thing is this here. You can download this programming cheat sheet. Got some of the rules in here, some of the qualifiers, the input activations or the input events. We'll get into the modcom too. It's not that hard, but it's easy to understand. That's like 7 or 8 or something like that. That's coming up. These are all what you get in a cheat sheet here. And when you click the link down, it takes you all the way over to the Rule Architect. All right, so you'll always have access to this. Let me get back to the screen. Where we at? There we go. Bruce, what's up, Bruce? How you doing? Thanks for joining. All right, so listen, that was enough of me talking, man. Y'all got any questions? I got a quiz in here. Hold on. We got some questions in here. If you have any issues with like handouts, I got a link in the chat. You should be able to get to at least the cheat sheet, or send me a message and I'll send it directly to you. Unless you got any questions, man, I'll catch you guys next week. This, one at the same time. So, I presented good way. Hope you learned something today, and I'll catch you guys next week, man. I appreciate you, man. Thanks.